Um, Good morning, all, and good morning, Asif and Amit. And thanks for taking your time over the weekend and then uh, uh, giving us a session. So, Asif and Amit had worked together in Huawei before, and they have been part of the open source for quite some time, for around 10 years. And Asif is working in basically in Kubernetes and cloud native. So, Asif is with VMware, and Amit is pursuing his freelancing in open source space. So over to you, Asif. I'll give you the host access and you'll be able to share your screen.
Yeah, thank you. Thank
Just
you,
give,
Roushan.
just give me 1 second. I'll just give you the host access. Okay, you're the host now. Let me know if you get the host access. I can
Yeah,
see
I
you're able to
received.
share this.
Okay. Yeah. Hope you guys are able to see my screen. Yeah. So, yeah. Good morning, everyone. So this is Asif, and today we are giving a session on service mesh with Istio. So this is more like a workshop plus a talk on what is service mesh and how Istio helps us to achieve the service mesh and how it helps to manage the applications and microservices. So before we start, okay, so let me introduce myself. So I'm Asif. I'm staff engineer at VMware, and I've been in this industry from last 10 years, and I've been working in and around Kubernetes and cloud native space. I'm also an open source enthusiast, so I like contribute a lot of my code and a lot of other things in the open source, and I have been a part of different communities, different open source communities like Apache Service Com, and I have been PMC member for different open source projects. And currently, right now, I'm working on mostly Tanzu portfolio of VMware. And with me here is Amit. So, Amit, would you like to introduce?
Yeah. Hey everyone, this is Amit. So I'm open source enthusiast. I've been working in the cloud technology for maybe almost 10 years, a decade, I would say. And um, I've been working in Kubernetes. I'm contributing in multiple open source projects, and currently I'm working with a Soda Foundation and maintainer of Kahu project over there. Over to you, Asif.
Yeah, thanks, Amit, for the introduction. So before we start, we'll just like to share the workflow of the complete this workshop. So we'll be starting with microservices, and then we'll try to see why we need service mesh and what are the advantages, disadvantages of service mesh, and what are different flavors of service mesh is available, and what is the typical architecture of the service mesh. And what is service mesh interface? We'll also see about that. And then we will start with Istio. We'll discuss about Istio architectures and features, and it will be followed by a demo of how to install and configure Istio. And we will also try to explain what all configurations are available with Istio and how we can use that configurations to manage the microservices. So here we start. So the basic building block of the service mesh, Istio, and everything is like microservices, right? So we would like to start with that, and we would like to set up the base so that we will be able to really relate each and every features with these things. So microservices, in a simple word, we can say it's a way of developing the software applications as a collection of small and independent services. And each of these services is responsible for only one specific business function. And these business functions communicates with each other using a well-defined APIs. So when we say e-services, these services are basically relatively small and easier to understand, and it has a loose coupling with each other, and it serves a single purpose and can be developed independently by different teams. So with this, what we mean is like all of these, the big applications can be broken down to a smaller service, and each of these services can serve just a single purpose. Logically, it should serve a single purpose, but when we break down the applications, it can serve one or two purposes, but by business logic, it should serve only one purpose, and it should be easier to understand and easier to develop. And it can be developed in an independent technology. It doesn't need like the technology stack of the complete application should be same across the microservices. It can be on a different technology stack as well. And we can easily decompose the applications using the microservices. And when we decompose these applications, we have the separate metrics and logging for all of these applications, and it becomes highly observable what is happening with these microservices. So you can easily debug, you can easily collect the metrics, you can easily understand what is the throughput and what is the way your microservices are performing, right? So with this, the basic characteristics we can come up to the basic characteristic of microservices. First, it is relatively small. Second, it has a bounded context. Like it is independent of the different microservices. It can be developed independently, deployed independently, and scaled independently. And it has it is language neutral, so you can choose your technology stack, and you can decide what's the best technology stack for your microservice, and you don't have to rely on the technology stack of the complete application. And it has its own code bases so that it can be again developed by independent teams and can be managed independently. So keeping all this characteristic of microservices, right? So if we see, if you go back like 10, 20 years back or 30 years back, right? There used to be basically monolith architecture where all the code and everything, all the business code, the UI, the data code, the data interfaces, everything was bundled up as a single software applications. And that was one single piece of a code which used to run on the main servers and everything. This used to work absolutely fine earlier, but as we go ahead, right, as the cloud native space got built up and then applications start moving to cloud and all, this monolith architecture was not suitable enough to actually run on cloud or run on any modern infrastructure because of the several reasons. One, like it was a big piece of software, it was difficult to upgrade, it was difficult to identify where the issues are happening because there were so many modules pumping up the logs in a single space, right? And when you try to scale the applications, since it's a single piece of a software, like you need to scale up completely. But there might be a situation like only user interface was overloaded, and the business layer and the data interface layer was like pretty okay. But since user interface was overloaded, you have to scale up to 10 or scale up to 5, right? So it was just wastage of resources, and it was not the best way to develop the applications. Still, right now, a lot of banking softwares are using the monolith architecture because of their needs. But but most of the applications right now running on the cloud native space are developed using microservices architecture. So what we did is from last 10 years, like we have been breaking down the monolith architecture to the microservices. So all the monolith applications gets converted to the microservices. And these microservices are very small pieces. And now they are developed independently, they are scaled up independently, deployed independently. So when these all are there, right? If you see right now, earlier, like in the monolith, right? The call goes to the monolith architecture and the call stays within it. So if user interface wants to communicate to business layer, the call is within the same binary or same modules as like a same network stack, right? It's not going outside anywhere. The calls are within. But when we move to the microservices, there were a lot of independent calls happening between the microservices. So you can see like a lot of extra arrows came up, right? These are basically HTTP or gRPC calls happening between two microservices. This was not there earlier in monolith. So when we moved to microservices, things became easy. Deployment, development of microservices became easy. But it brought up some new challenges. These new challenges are basically these arrows. This is what the communication between the microservices. And when this happened, there were a lot of challenges which came in. So if you see about the challenges, first was the complexity. Complexity of what? Complexity of the integration between these microservices, because right now all the basic blocks are like independent of each other. And now they have to be integrated to form a single application, right? So the complexity of integration was very huge. And then the communication and the service discovery, that became a big challenge. Like how the microservice, say the UI microservice wants to connect to say a data layer or a business core layer, right? So they needs to identify where all these microservices are running. And based on that, and it has to be dynamic. Like if say some things, your microservices are running on a Kubernetes type of thing, right? So this has to be like the service discovery has to be dynamic. Whenever the application goes up or microservice goes up or goes down, right? They need to discover each other and they need for the communication. And the third important was the service contracts. Like all of these microservices was communicating with each other using some APIs. So these APIs have to be a proper contract saying that, okay, this is my microservice and I will be exposing these APIs. So if you want to connect and get my services, you have to call these APIs, right? So that was one of the complexity which was there earlier when the microservices came up. Slowly, that has been removed by following a well-defined APIs and everything. And still, the second challenge is the lack of experience. A lot of people just think like uh, making the from moving the monolith applications to microservices, you just break down the application into smaller parts and then it's done. It's not like that. You have to logically break down the microservices, break down the monolith applications, keeping all the mind like how the calls are going and how what is the relationship between different modules. So that is one of the challenges. And the third challenge is the distributed system. So earlier, if you see the monolith architecture, everything was one single piece of code. So the fault tolerance or the logging and the monitoring of those applications and the security was quite easy. But when we move to microservices, if one microservice goes down, should your complete application goes down? Or just one particular microservice should get affected. So these all fault tolerance things came up when we moved to microservice, and then the logging and monitoring was again one of the challenges only earlier. Now there are a lot of plugins and everything which take care of the logging and monitoring, but earlier it was one of the challenges. And then the security in the sense like earlier in monolith, like just the call goes in and the call remains in the same process, right? But here the calls will be flowing through one microservices to the other microservices. Now, whether these calls happening between inter microservices, right? Whether that has to be secured or that has to follow some TLS or something. So that was one of the challenge. And for all of these complexities and everything, right? There are so many frameworks which are available in the market to solve these problems. So I can like there are more than 100, 200 different microservices framework available in the market for different languages. So it's a very confusion state of what you should select to solve your problems for your microservices, which framework you should use so that you can achieve your business goals. So keeping all of these challenges in mind, right? If there are any microservices framework or if someone is trying to develop the microservices framework, right? What we think is these are the major requirements for any of these microservice framework. And most of the microservices and microservice frameworks in the market tries to address these challenges. So first one is service discovery. So if I take an example of the front end catalog, so say this is a simple e-commerce application, you can say, which has like 5 different microservices. The first one is the front end, which connects with the catalog, carts, and orders, and then carts connects with payments. So this is just an example. This is just a simple example of the microservice, and we will take this example to illustrate all of these major requirements by the microservice frameworks. So first thing is like say front end wants to connect to catalog, right? And say a catalog is running in some another server or somewhere, right? And it's probably not in the same machine as the same machine. So if front end wants to connect to catalog, front end needs to know where the catalog is running, what is the IP port of the catalog, right? And if say wherever the catalog was running, if that goes down and somewhere else the catalog comes up, right? Front end should get an update saying that okay, this instance of catalog is down and the new instance is up, and that's the IP and port. So this is the service discovery. So service discovery plays a very important role in any of the microservices framework. So with the service discovery itself, one microservice is able to communicate to other microservice, and these all service discovery should happen dynamically. Like it should not be like a hard-coded thing. Okay, the catalog is going to run on this, and it will keep running on this. Because if you go to cloud native space, right? The way the containers comes up and goes down is like very frequent and very dynamic, right? So service discovery should be very dynamic one. Second is the load balancing. Say if frontend wants to communicate to catalog, and that catalog had 3 instances of it running, right, with on different IPs and ports. So a frontend needs to decide like on which IP and port it needs to connect, and it should be able to balance the load. Say there are 3 calls happening, so first call should go to first instance, second or third. So this all can be defined by the different policies. It can be basically by default, generally it's a round robin, but you can write your own algorithm and plug in as well, right? So this is load balancing is also one of the major requirements for any of the microservice framework. And then comes the route management. So route management is basically like, okay, you are saying that, okay, for catalog, these are my APIs, okay, and these are the version 1, version 2 APIs and something. And say if frontend wants to communicate to us, they need to call this API with this particular version so that the call reaches to the catalog. So this is basically telling that, okay, how my APIs or how my service contracts have been laid down. So the route management is also one of the major requirements, right? And then the circuit breaking. So circuit breaking is something like if one microservice goes down, right? It should not be a cascading failure. It should not be like one microservice goes down and your complete application goes down. If one microservice goes down, you just isolate that microservice and let the other microservices run. Say if the card microservice goes down, right? Front end should still be working with the limited features of the catalog and orders. If just card goes down, others should not get impacted. So basically, that helps you to manage the retries and manage the circuit breaking and all. And then comes the rate limiting. Rate limiting is basically you tell these microservices, okay, this is my limit. Say my limit is 100 requests per second. So I won't be serving more than 100 requests per second. If there is more requests coming into that, either queue it or drop it based on the different policies you configure. And then comes the security. Security is like these applications communicating to each other, whether there should be proper authentication authorization required, or whether it should be following some certificate mechanism to do the authentications and authorizations, so that you can say if some other microservice is trying to connect to catalog, right? So catalog should know which all microservices can connect to them. If say there are another microservice, say some XYZ trying to connect to catalog should reject the call, saying that, okay, I don't recognize this microservice. This microservice shouldn't be calling me. So these type of features should be there. And then the metrics and logging. So again, the metrics and loggings is like collecting the logs and the metrics of the CPU memory and the application code itself. So as I said, like these are the major requirements which should be there in any of the microservice framework, whether it's a service mesh, Istio, or whatever, right? It should try to resolve these all major things. Some of the microservice frameworks resolve some subset of these features, or some of them addresses all of them, addresses all of these requirements. But if you see, all the frameworks are based on these particular requirements. So it's not more than that or not less than that. It's mostly follow these. So with that, I will just wait for a second if you guys have any question. Anyone? Okay, cool. Then let's go ahead. So based on all of these requirements for the microservices framework, right, people or companies or communities started developing SDKs. So these SDKs earlier, like if you go 5 to 10 years back, these SDKs were majorly focused on one technology stack, each of these, like say Spring Cloud, Spring Boot, right? that was more focused on Java applications. If you come to Go Micro, it was more focused on Go applications. If you go Angular Mesh and Aspen Mesh and all, right, it was focused only on Angular applications. So companies started writing SDKs following all of these major requirements, and they started addressing all of these. But the main problem was all of them was focused only on their technology stack. But there can be situations where in one single application, there can be 10 microservices, and all of them can be on a different stack based on, because that was one of the core principles when we started microservice, right? That you get an option to choose your technology stack. So that became a problem. So when the SDKs were formed, keeping all these requirements in mind, that used to work fine if your complete application or complete all the microservices are built on one technology stack. So say if you have a Java application which has like 10 microservices all written in Java, right? So Spring Cloud or Spring Boot should be was good enough to address all of these things, because all were using the same SDKs and they were able to do service discovery, load balancing, route management, and everything. But what if application there are two microservices, one is written in Java and another is written in Go? Then that becomes a problem. The Spring Cloud, Spring Boot might not be compatible. The SDKs might not be compatible with Go Micro. So these SDKs, in some places, those were compatible. In some places, those were not compatible. So if you take an example of ServiceCom, right? ServiceCom has two SDKs, Java SDK and Go SDK, and they both can work together. But what if there is a Node.js application? Again, that ServiceCom will not be able to resolve that, right? So, all the requirements were addressed for microservices, but they were addressed in their independent SDKs, and those SDKs might sometimes be compatible, might not be compatible. So that again became a problem for developers or for analysts or for consultants to choose which SDK is best for their application. So if you just imagine, if the same example we were trying, right? If the same example has different 5 microservices and all written on a different technology stack, then how do you resolve this? So I would like to give you 30 seconds. Just think about it. If the situation like this happens, right, where all your microservices are written on different technology stack, and say everyone has their own SDKs to do the service discovery, load balancing, and all. So the way the service discovery is done in, say, Angular is not equivalent, or it doesn't have a same standard of service discovery being done in Node.js, right? So there can be a mismatch of the data or the way the traffic management is done, right? So in these cases, what is the best way to handle it? Take 1 minute and please tell, like, if say you are an architect, or if you are from the engineering standpoint, right, what will be the best solution to address this issue? Anyone want to give a try?
Registry need to be separated, and we need to be a common registry kind of thing.
Exactly. Yeah. Thanks, Arul. Thanks for that. Yeah. So not just registry. So what we can do is all the framework piece, right? The piece of code which does these, which basically does this service discovery, load balancing, route management, and all, right? This can be a separate piece of a code, and we can separate the app code separately. So till now in SDKs, what used to happen is, like, say Go Micro, right? So you just import some of the Go Micro packages, okay, and you do a basic configuration and you build your app microservice. So what happens is all the code related to this service discovery, load balancing, and all I integrated into the application code itself. So it becomes like one single piece of a binary which has all of these things. But again, if the same application is written in Java, you need to go and change the SDK. You need to go and change the way it has been configured and everything. So what will be the best way is, like, you break down this framework into a separate piece of a code, and then have all these service discovery, load balancing, and other stuffs in a separate binary and keep your application or the business logic separate. So with this came the sidecars. So the main motive of sidecars was to address the issues which SDKs brought in the market, right? So what you do is you have a separate binary for the frameworks and you have a separate binary for app code. So now the app code has an option, or basically has can actually leverage different technology stacks. So now the framework can be in some, say it is in Go, right? It is in Go language. And app code can be on Java, can be on Node.js or whatever. So with this, the first core principle of microservices, like you can choose a technology stack. Now that can be addressed seamlessly. So if you see, this is the basic typical example of sidecar, like a framework different and app code different. And if you see the example of sidecar on Kubernetes, so this is basically what we call it as a pod, which has a logical grouping of the containers and which shares the same network space. And your containers, the app code can run on one of the containers and the framework can run on another container, both in the same pod. And the only thing is all the incoming and outgoing traffic is intercepted by framework. So why do we do this? Like why do we intercept all the traffic for the framework? So that any call which is going, say app code, like the container one is trying to connect to some microservice, right? And it just knows the name of the microservice. The framework, what it will do is it will, in the runtime, it will go identify, okay, this microservice is running where. Okay, say, okay, this microservice is running on some particular IPN port and it has 10 instances of it. So framework will identify, okay, out of these 10 instances, which instance it should go and connect. Okay, or which instance is active, like in last like 10 calls, which doesn't have a failure or something, right? So framework will be intelligent enough to do all this traffic management and all. And all of this was possible just because of the very simple thing, which probably everyone would have used, the HTTP proxy. So basically we configure the HTTP proxy on the container one, and we let all the calls which are incoming or outgoing go through the framework. So we set the proxy to the framework container. So with this, we can achieve the sidecar in the Kubernetes, and this becomes the basic block of service mesh or sidecars which are available in the market. So this will be very important going ahead in our work in next 1 or 2 hours. So if you guys have any question, you can ask now. It seems everyone has understood. That's nice. So with this, we start with the service mesh. So what is service mesh? It's a dedicated infrastructure layer for managing communication between all the microservices. So basically it's a framework. What in our last example, what we mentioned, the frameworks here in the container two. Basically service mesh is that which manages all the communications between the microservices, okay, and which also caters like, okay, service discovery, load balancing, circuit breaker, metrics tracing, and security. So all of these features, right, come inside the service mesh itself, inside the framework itself. So now the developers, right, don't need to worry about this discovery, load balancing, and all of that has been taken care by the service mesh. Developers can just focus on their business core applications and all, and they don't need to worry about the microservices communication. And most of these service meshes are typically implemented using a sidecar proxy. And this sidecar proxy is basically the small piece of a software that runs alongside each microservices. So with the service mesh, just like the SDKs were there, right, before for Golang, for Java or Golang and all, right. Now it's a service mesh, okay, which handles all of this, and it's an independent of the technology stack of your microservice. So it doesn't care in what language your microservices are written. And it can some of them so there are a lot of variants of the service mesh. Some of them are built inherently into the Kubernetes, and some of them also works outside the Kubernetes. So if your applications are not running on Kubernetes, it can still work on direct servers as well. So what are the benefits and challenges which came with the service mesh, right? First one is the performance. Since all of these traffic managements and everything, right, was taken out from the application performance improved, and the service mesh was just doing the traffic and communications, traffic, handling the traffic across different microservices. So this basically improved the performance and the way the microservices are connecting to each other. And since all the loads were getting distributed properly, and then there was a retry mechanism, and then everything was in place. So this basically helps to reduce the latency and improve the throughput of the microservices. And second is the reliability. With reliability, what we mean is, again, the circuit breaker and retries. Like if there is one microservices which are going to fail, or which is have been failing for over time, right? That should not be a cascading failure. It should let other microservices or other features of the application still work properly. So this frameworks enables this thing. Like it will identify which of the microservices has been failing, and it will actually reject the calls. The call should not go to that microservice and then fail. It's like the fail early situation. So with that, we ensure the applications are reliable, and you can identify, you can put how many retries. If some application is failing because of some of the network issues or something, you can say, okay, how many retries should be there, and what will be the nature of the retries. And also by this, basically we can ensure that, okay, the reliability of the applications will be there. The reliability of what, not the applications going down or up, the communications happening between the microservices, the reliability of those will be ensured, not the applications. And then again, the security. So it also ensures that all the calls which are happening through one microservice to another microservices have an encryption and a proper authentication, and it prevents applications from the attack. Attack in the sense, like if you don't have your own framework or something, if say attacker enters one of the microservice, right, then it should not be a scene like, if attacker has entered one of the microservices, it should be able to call other microservices without any restrictions. So intercommunication between the microservices should be very secure, so that even if attack happens on one microservices, it should not, the other microservices should not fall back on that. Right. So with this, we can ensure that, okay, if you are using any of the service mesh and all, right, you can assure that, okay, there will be a good performance between the communication of the microservices, and it will be quite reliable and secure. But again, whenever these things get addressed, right, there are some challenges which comes in. Say when SDKs were made for service frameworks, right, microservice frameworks, there were a lot of challenges which also came in with that. Same way with the service mesh also, there are some challenges. One is the complexity, because all of these things are built into one framework, and now all of these frameworks need some configurations to actually address all these features. Say load balancing, what will be the algorithm for the load balancing, or what will be the configuration, or what will be the policies for circuit breaking and retries and all. So this brought in some complexity, but the good thing was this complexity was same across the complete microservice. Like if you have an application with different technology stack of microservices, the complexity of communicating through each other was just one. If you identify how to configure the service mesh, and then it's done. So the complexity was there, but it was not that great. And the cost, obviously, because with each of your microservices, there will be one more container running into it, and you need to maintain these containers and all, right. So it associates the cost in the sense of like resources and everything. So that will be cost. And then the vendor lock-in. Vendor lock-in is something like, if you now say you are trying to use one of the service mesh, and say you want to move it to another service mesh, right? So again, it is like a change of the SDKs and all. Then in that case, what happens, like the configuration plays an important role. So again, you need to go and change the configurations and everything. The application will remain same, but the configuration of your service mesh needs to again change. So that is one of the vendor lock-in issues which we face in the service mesh. So with this challenges and all, if you see what is the typical architecture of service mesh, so if you go to any of the service mesh, right, it will be doing most of the requirements what we discussed before, like load balancing, service discovery, and all. But the way it will be addressed is something like all these configurations of the load balancing or service discovery or like traffic management, circuit breaking, retries. All of these can be done on the service mesh control plane, where all the configuration and the policy lies. And then these configuration and policies, when needed, will be pushed down to the proxies. The proxies are basically our frameworks where all of the actual data plane thing happens. Like when the call is actually going to connect from service A to service B, the service discovery and all of these things will be happening in the proxy itself. But how the proxy will behave, those policies comes down from the control plane. So with this, we are segregating the way the policies are configured in the control plane, and then the way the policies are actually used in the data plane. So if you go to any of the service mesh right now in the market, all will follow almost the similar structure. With this, we just segregate the users so that like if any policy needs to be done, uh, those policies should not directly interact with service A, service B, or service C. The policy, the validation of the policies and everything happens on the control plane itself. And once everything is validated, and once everything has been like put into a particular structure, then those policies are pushed down to the proxies. So with this, the reliability and the segregation of the policies happens. So with this typical architecture, right? So people might say, okay, this is basically doing the service discovery and all, right? And you need to run the service mesh separately in the control plane and these proxies and all, and it's incurring some cost, right? Cost in terms of resources. So why not just go ahead and use the Kubernetes service, which is already there in Kubernetes inbuilt, right? We can use Kubernetes services to some extent, but if you come to have like if you want to use some advanced way of managing the communications and all, that cannot be done on the Kubernetes service. The sole purpose of service mesh and Kubernetes service is slightly different. Service mesh tries to uh, manage the microservices communication, whereas Kubernetes service tries to logically group the pods and expose them to a single point of access to them, right? So Kubernetes service is mostly for the service discovery, whereas the service mesh is managing the whole communication, not just the discovery, but the other stuffs as well, like traffic management, security, and observability. So service mesh is catering to these, whereas Kubernetes service just cares about load balancing and the DNS resolution. It doesn't care about how the traffic is moving from one application to another application and what are the securities that needs to be there while communicating from one microservice to another microservice. And obviously Kubernetes service just focuses on two of the things, so it's very simple to use, and but it's simple to use, but it cannot cater to a large scale of microservices and applications. Say you have uh, like hundreds of microservices which have been scaled to like thousands of instances, each running on different zones and different availability zones and different data centers, right? So in those scenarios, Kubernetes service might not be the best choice. But in those scenarios, service mesh can definitely cater to those particular instances. So with this, like Kubernetes service is a good option if you are starting with the microservices and all. Okay, just for the trial purpose and everything. But if you want to have a production-ready microservices and your applications, then service mesh becomes a de facto choice for that. So with this again, now the service mesh technology was there. So again, just the way in SDKs, right? When the SDKs were built, all of these companies and different communities started making their own SDKs, like Go SDK, Java SDK, and all. The same way, when service mesh was there, people and companies started writing their own implementation of service mesh. And some of the communities. So first is Istio, and then Istio is there, Linkerd is there, AWS App Mesh is there, Console Connect is there. At least as of now, there are more than like 20 to 50 different implementations of service mesh, which is available in the open source and the proprietary softwares. Okay, and all tries to address the major requirements what we discussed before, tries to address those, but in their own way. Some are focused on on-prem solutions, some are focused on cloud solutions, and some are focused on their particular cloud applications, say AWS App Mesh. So say if your microservices are mostly dependent on different AWS services, right? And your application, your microservices, you are planning to run on AWS only. So AWS App Mesh might be a great choice, right? Say you are just trying to use it on Kubernetes and all, Istio, Linkerd, Console Connect. This can be a best choice. So all of these are either a subset of each other or equivalent to each other, but catering to different developers on a different platform. So mostly they are same, but again now with service mesh, again the problem is now there will be so many implementations of service mesh. Now you will have a difficulty to choose what is the best service mesh for you. Okay, and how do you prevent the vendor lock-in issues? Like today, say I am running my applications using Istio, like, right? But Istio probably might not be giving some features or something, and I want to move to AWS App Mesh. Now there will be again a movement from Istio to App Mesh. Again, you have to reconfigure everything. The configurations what were available in the Istios might be quite different from the configurations available on AWS App Mesh. So again, the problem what used to be there on SDK side, now that problem is still there on service mesh side, right? Earlier, we used to like change the applications when we are moving from one technology stack to another. Now, if we are moving from one platform to another platform, there is a vendor lock-in issues, and you need to change all the configurations, and you need to adapt to the new configurations. So that issue is still there. So addressing this issue, there came the service mesh interfaces. So before we start this, how many of you knows cloud CSI, CSI or CNI or CPI, like cloud provider interfaces, cloud network interfaces, or cloud storage interfaces? Any of you already knows about these CNI, CPI, and CSI in Kubernetes? Okay, so
Yeah.
Regine,
Yeah, so these are some standards defined to ensure how different vendors can develop their products, so it can work with the orchestration technologies.
Yes, yeah, right. That's correct. So say if we take an example of CSI, container storage interfaces, right? So there are so many providers of storage, right? There are people from NetApp, there are people from IBM, there are people from VMware, all having their own data layers, right? So if some containers wants to use these interfaces, right, wants to connect to, say today, NetApp storage, right, and tomorrow they want to move it to IBM storage, again that shift will be required. So the community came up and they formed a standard called as container storage interfaces, where there will be some interfaces which will be defined above these, and all these data providers, right, will have to use these standards so that all the containers can actually use it. So it's basically standardization of all the interfaces across different vendors. So the same way, service mesh also has an interface, SMI, which defines the standard of the APIs. Standard of APIs of what? The way we configure these applications, the way we configure the service discovery, the way we configure the traffic policies, telemetry, and management. So, so the community came up with the SMIs, so that today, if you are running an application on one of the service mesh, tomorrow, if you want to move to another service mesh, you basically don't need to do anything. Just a basic simple configuration change will be enough, because all of these service mesh frameworks will be adhering to one of the standards which are defined by SMI. So with that, we resolve a lot of issues of moving from one service mesh to another service mesh, and also the standardization of how we configure. So in some cases, say in some cases, like some policies which were being used in Linkerd, was quite different from the policies for traffic management which was used in Istio. Now, when SMI coming into the place, the policy, the way we configure that will remain the same. So with that, it brought a lot of ease for users to use the service mesh in a very standard way in Kubernetes. So this SMI only caters to Kubernetes, and it is built on the custom resource definitions. It has different CRDs, which helps to configure these policies. So right now in the current ecosystem, if you see all of these microservices, all of these service mesh uses SMI standards. So say if today you are running your service mesh using Meshri, right? If you are using Meshri, and tomorrow if you feel like, okay, Meshri is not a good choice, right? And if you want to move to Linkerd, the CRDs and everything, the configuration remains the same. You just need to do a simple configuration change and you can start using Linkerd. And this way we try to resolve all the challenges which we addressed before in the SDKs or in the service mesh. So now we can say this microservices, the complete ecosystem is well defined for people to use, and it is backed by multiple communities. So now we can say like the microservices, the complete framework and everything has reached to like a production ready stuff. And now it can be used seamlessly across different platforms, across different solutions. Yeah. I think that's all from the service mesh side. So we'll be starting with the Istio. So before that, we will take a 10 minutes break and then we can start. So we can come back around, right now it's 11:02. We can come back around 11:15 and we'll start again. In between, if you guys have any questions, you can just ping in the chat and we will address those questions. Yep. Then let's meet after 11:15, right, Pavitra? That should be okay.
Sure, Asif. Yeah, sounds good.
Should be fine.
Yeah.
Yeah.
And we have some announcements on the chat, so maybe if you get some time, you can quickly go through that. Thank you.
Asif, I think you are
Asif,
not
we don't
audible.
hear you.
Hello, Asif. You're not audible. Hi guys, am I audible? To all?
Hey, Amit, you're audible.
Okay,
We're
okay.
not able to hear Asif.
Okay. Maybe Asif, shall we wait for some more time, or shall we start immediately? Pavitra?
Yeah, Amit, will this be your session?
Yes, yes. Going forward, it would be mostly my session, and Asif will join, and
Sure
we'll
thing.
conclude then.
Yeah. You can go ahead, Amit. Maybe I'll Asif.
Yeah. Asif, can you make Amit as the host so that he'll be able to share his screen?
Hello, can you guys hear me now?
Yes.
Yeah, now we're able
Oh
to hear you.
man, I have been talking from last 2-3 minutes.
Okay.
Yes.
Yeah, can you share the host access to Amit, roll the host access to Amit so that he'll be able to share the screen?
Okay. So hope everyone is back. Can we get a thumbs up from all the back?
Okay.
Yeah. Cool.
Am I audible, and is my screen visible to all?
Yes, sir.
Okay, good. So hi guys. Now I'm going to take you through Istio, but before that, let me just give a summary what Asif has explained. He started with the monolithic application, the problem with monolithic application, then microservice came into being, and then with microservices there are some complexities came along, and then there was a set of problems which been solved by different frameworks, and then there was some vendor locking, there was some complexity involved in those frameworks. Service mesh came and solved those problems, and then further there were some problem with vendor locking with service mesh also, and then SMI came and solved all those problems. Now we are going to discuss Istio, which is a open source implementation of the service mesh. This project been started by Google, IBM, and Lyft, and they have contributed to open source community. And this particular implementation solves each and is an exact implementation of service mesh, which takes care of the reliability of the traffic between two microservices. It ensures the resiliency of the traffic, and then out of box implementation for service discovery, load balancing, security, observability, all those features has been inbuilt in Istio. Okay, to answer why Istio is needed, I think Asif has explained it already. Like because it's a service mesh implementation, the common set of problem which we have in microservices, which involves the because it's distributed in nature, so there will be always a there has to be a reliability of communication between two microservices. Along with that, there has to be the DFX requirement solved, which is related to the telemetry auditing. Then again, it has to be secured as a basic feature. So all these, like Istio the answer of this question, why we need to use the Istio, is the feature set which we have in service mesh. Now, moving along to why and how does Istio work. So I'll just take you to the top level view of how the Istio architecture is, which is the same thing, which is the generic service mesh architecture. So we have a data plane, and then we have a control plane. So all the policies, all the configurations, and all the certificate management and everything is being managed and maintained by the control plane. But the core entity of this service mesh is proxy. By default, Istio use invite proxy as implementation. So this the proxy, invite proxy, will be running alongside your services and sitting in between the traffic, either coming outside the mesh or service to service traffic is there. All those traffics, or maybe if the traffic is going out, all those traffics are going to pass by the invite proxy. So what control plane does is all and every information which has been configured by the user will be passed to the proxy, so that the chattiness of the services can be resolved. Like for each and every request, one should the proxy should not come and communicate with the control plane and pull the information, rather than as and when the configurations has been changed or the policy has been changed, so those policy has been pushed down to the proxy, and the proxy takes care of all the decision based on the configurations available and configured through the control plane. Okay, so that is a very top level architecture we have for service mesh, and for that matter, Istio for data plane, we have a invite proxy and invite for the sake of completeness, let me give you some information on invite proxy. It's a C++ implementation wherein it supports load balancing from L3 to L6, and all those service reliability mechanism which we are talking about for service mesh, like circuit breaking, timeout, retry, and all load balancing and everything is being supported by invite proxy. The only thing and what we do is from control plane is to take the configuration which user understands and translate it which how the invite proxy understand it, and pass it to the proxy, and further invite proxy will take care of everything. Okay, now when we talk about the control plane, there are three major components over here, which one is the pilot, which is related to the discovery. So what all services we are deploying in the Istio, all those services will be discovered by pilot. So how it does is basically it gets integrated with the service discovery of the platform system itself. So for example, if we are deploying it on Kubernetes, it will get integrated itself with our core DNS. So all the information of service information will be pulled from there and will be passed on all those information, the service information, to the proxy, so that it will have the all service information within. Okay, now Citadel is all about the certificate management system. Because it is a service mesh, so we need to ensure the end-to-end security of whatever communication being done from one service to other service, or the information coming from or the traffic coming from outside or going outside, all has to be secured. So all those certificate management will be done by Citadel. Also, it supports certificate rotation as well. Now, Galley is another component, which what it does is basically all those configuration we pass on, the policy which we pass on, its validation, ingestion, aggregation, and everything will be done by Galley and will be passed down to the proxy. This is how it is. Actually, traditionally, all these component, all those modules were microservices, but they were very chatty in nature. So eventually what the community has done is to all those microservices are uh, uh, put together in a single process, which we call as Istio. So currently, all these components are part of a single pod and process, which is we call as a Istio. Maybe microservice is not always a solution for everything. There could be some scenario where even monolithic application works better. So yeah, so this is a high-level architecture of Istio mesh, and I am going to take some pause over here. So if somebody has some question or something, please feel free to ask. Okay, then I'm gonna move further. So the now further, I'm gonna take the session to the three basic entities, three basic features which Istio supports, which is one is traffic management, and then security, and then you have observability in place. So the traffic management is all about whatever traffic, controlling, managing, and defining policies for all the traffic which is coming to the services, either between service to service, coming from outside to the service, or going out to the service. All those uh, uh, traffics will be managed and maintained by traffic management system. Also, it do involve the service discovery part, wherein each and every service will be discovered and identified, and unique identity information will be given to that. Now, as I explained earlier, all those policies, configuration, information, uh, all those information and everything will be finally pushed down to the envoy proxy. So that is what the traffic management system is. We will explore more how it has been done and which are entities or which all abstractions are there in Istio which help us to for the traffic management coming in after some slides. Now, the second thing which we this Istio provides is the security, and this is the most important uh, area which most of the industry will look into, which out of box been supported inside Istio, which is the traffic encryption. So all the data which is going along on the wire are being encrypted, and it also supports authentication authorization through mutual TLS. So what it does is, for each and every workload there will be a certificate generated. Now if it is a client, and if it is connected to the server, what the basic nature of mutual TLS is to validate whether the server certificate is when it is trying to communicate with the different service. What it would do is a client will validate whether the server certificate is valid or not. Okay, a mutual TLS will have a course certificate with that, a root certificate, and with that it will validate whether the certificate has been signed by the root certificate or not. Similarly, for the server, it would also validate whether the certificate shared by the client is valid or not. That is the first thing it would ensure. And the second thing, it would ensure that for the auditing purpose, it will also maintain the information of which user is trying to connect with for this particular or for a particular API, and also stuff. These are the basic security feature and functionalities being provided by Istio. Okay, coming to the observability part. So this is the most, one of the DFX each and every component would have, because this ensures this basically observability highlights the reliability of the system, whether your system is working fine or not. So it involves, it has three pillars basically. One is your metric collection, other is tracing, and the log management. So in Istio, by default for observability, different components are already been integrated, like metrics. Each by default, Prometheus has been integrated with Istio, and Envoy proxy supports giving all the metric related information, like what is the latency of a particular request, how many requests successful, failure, how much time it took to complete one request, what is the saturation of that particular request, and also with the same uh, it supports open telemetry APIs. So and with that, and then again it also supports a tracing system, with which you can say that you can trace back that a particular request being served by which all microservices, and where it would fail, or how much time each and every microservice took to process a particular request, and also information. And logging of each and every request is a basic requirement for the observability point of view. So these are the three major verticals Istio provides and will solve this common set of problem, so that the developer, right, can concentrate mostly on developing the business logic, and they can easily develop the distributed microservice architecture. So now these are the things. I'll just again take some pause, and because now further on I'm gonna move on to the demo. So before that, I'm just gonna take some pause, and I'm just waiting for some question or something. Okay, moving along. So Istio deployment currently supports three standard way of Istio deployment on. Okay, basically the currently Istio supports two variant of deployment. One is on Kubernetes, and the other one is on VM. Personally, I have not tested or worked on VM deployment, but mostly I have worked on the Kubernetes, so which I am gonna take you through. Now, there are three ways currently Istio supports to deploy on Kubernetes. One is Istio CTL, which is a which is a client. It's a binary, statically linked binary. What it does is basically it is configured with all the information, pre-configured with all the information. It has a couple of profiles as a command line argument, and with those profiles, it would try to deploy a particular Istio implementation on Kubernetes system. So based on the profile, you would get different components deployed on Kubernetes system. So most of the profiles are like demo, default, like remote, local. Also, so basically, if you take get all these profiles, each and every profile is linked with a particular custom configuration. If you there is a way of altering the configurations as well, but Istio comes along with the default these four flavors of I think 5 flavors of profiles. So for this demo purpose, I have used demo profile, so which would deploy the basic Istio service mesh inside the Kubernetes cluster, which involves deploying your Istio D and envoy proxy for each and every services. Now, other way of deployment is standalone operator. What it does is actual operator, like it's a controller which will be running inside the Kubernetes cluster. And personally, I believe for any production grade environment, the standalone operator is the best pick, because all the operational knowledge is built inside the operator, standalone operator. So it would have all the configuration information, and those configuration you can customize, and you can give that configuration to the operator. It would based on the information, it would deploy the complete service mesh, Istio service mesh inside the Kubernetes cluster. It would also support the installation, upgrade, downgrade, and also scenario. And for that matter, Istio CTL also supports this, but Istio CTLs are mostly, in my personal experience, are mostly for the demo and some basic POC purposes. But personally, I believe is still standalone operator is the best pick for the production grade environment. Now, custom Helm charts are the like a legacy way of deploying Istio CTL. Currently, I believe it is not been used much. But these are the basic Helm chart. Like it is basic Helm chart in configurations, which will have multiple configurations, multiple CRDs inside it, and those CRDs with Helm, you will be able to use the Helm command to deploy inside the Kubernetes cluster. So these are the basic deployment approaches we have. I'm gonna take a pause here, and I'm gonna move to the demo how I have deployed in my cluster Istio. So I'll just move to my demo section. And before that, if anyone has any question, please do interrupt me in between. It's feel free. Okay. Okay. So for Istio deployment, what we need is a Istio CTL binary. So the Istio CTL binary with the latest release can be pulled from here, downloaded with this command. If you see this this particular script, what it has is basically it would download a script, and it will run that particular script to download. Basically, this script will do is identify which platform you are working on, and based on the platform, it will download the binaries. And again, if you have very specific version of Istio to be get deployed, you can specify the version over here, and based on that version and architecture, it would like the same script will download the binary. And what you need to do is to use that, put that binary in the path so that you can readily use it. Okay. Okay. As I was talking about profile earlier, so these are the profiles we have for Istio CTL. So I just show it to you. When I run that command, this one. So what it does is basically, yeah. So this is the script. Okay. And based on the different variant of OS and architecture, it would try to pull the binary. Okay. And will keep it in one folder based on the version. This is going to be that one. So it will, and this folder would have that binary inside. Okay, sorry. Yeah. Yeah. So this is the CTL you will have. So if you see, I have that in my path so that I can easily use. Yeah. Okay. So basically this is a way of like, this is like quick way of you deploying Istio on service mesh. So I'm gonna use Istio CTL. So the next set So yeah, so let me, okay, this is only downloading part. And then, okay, now then what we need to do is to run the command. Let me just, yeah. So this is the command we have, Istio serial install, and this is the profile setting part. So I've set this profile for demo purpose, so that it will be easy for a basic set of deployment to be get done and show the demo. So I'll just run this command. So while after running this command, it takes some time, but what you will get is some CRDs gets installed. Okay, and along with that, these are the set of process which is going to get installed over here. So you can see you would have Istio D installed. Okay, and that is only what it is going to be. The ingress is I mean, we are going to cover that ingress and egress part later on. This Grafana, Agar, and Kiali, all these components are the Prometheus, and all these components are add-ons for the observability point of view. But the basic set of processes which is going to get deployed are these three. Okay, so this will have your pilot, galley, and citadel modules inside this, and yeah, that's pretty much it. Okay, okay, now yeah, so now moving to the, for the demo purpose, I chose a specific application, and all this demo and the commands are available on istio.io. So all this demo links and everything is available on istio.io. So anyone can go and check after this workshop. Anyone can go and refer that istio.io. Now, so moving to book information application. So basically, it is a multilinguist application which works in like the common deployment is like it would have a Java application. So basically, it's a book review application. So what it has is a product page. This is a website, a portal, which will be connected to by the browser. And what it does, it will publish all different kind of book information. Currently, for this demo, this application is only single book, and what it does is it would connect to further different microservices, and these microservices are basically written in Java, and each and every microservice has different version, like version 1, 2, and 3, and each and every version has identity as in how reviews has been provided. So this review v1 process doesn't have anything like stars, like ranking system, but this review v2 will have ranks. I mean the rank of the this book, and that is in black. Stars basically is in black, but for v3 it is in red. So I'll just open that application. Yeah, so if you see this, this is the product page application. So this is how it looks like. So if you see, it will keep changing as you refresh every time. It will keep changing because this product page application will be gonna connect with for each and every request. It will connect with a review microservice, and this is further connecting with the rating microservice. So what it does is over here is this will be load balanced across different different microservices. So each time you hit different book review, like review microservice will get hit, and based on that you will see this side of the web page changing, because based on the ranks, ratings, this will change. So basically this is V1 currently been served, and if you see it is V2, and maybe if we are lucky it would come, but let's see. Okay, yeah, this is V3. Okay, so this is how it is, and this is the rating, and which would be shown here. Okay, based on the rating, this is stars would come. Okay, and then the details of the books are coming from straight from this Ruby application. So as Asif was explaining, one of the basic problem with the monolithic application was to like the stack was very very specific to some language or something like that. So with microservice architecture, you can choose your stack. So this is that application which we have. The complete solution has multiple different kind of language stack, and all of we are able through service mesh, we are able to serve the complete end-to-end functionality of this particular application. So this is what book application is, and using the same application we are gonna do all those verification for like traffic management, the security part, the observability part, all those for the complete demo we are going to use the same application. That's why I took time to explain this complete application as of now. Okay, now
Amit,
okay,
before we start to the next one, if someone wants to try it out right now, deploying Istio, they can try it out. If you guys face any problem, like just bring it up and we'll try to resolve that as well.
Yeah.
So Amit, would you like to take a break? Because I think so the next slide when we start, like we have to go non-stop, right?
Yes, yeah, I think till now this is all theory part. Let me just take one more
Okay.
theory.
Okay,
And after
so
that we
Amit,
will take
after
break. Yeah.
after that we will take a break, but yeah, we are taking a break so that you guys can go try install Istio and see if you face any problem or something, and we'll be happy to help you guys.
Yeah. So basically for my environment, I use kind, which is very easy thing to get a spin a Kubernetes cluster. So please do use kind, and you might not need anything other than kind. One additional thing is if you are trying out some ingress and egress kind of scenarios, then you might need a load balancer. So by default, it has been integrated with Metal LB load balancer. So which will be available the istio.io will have a link, and through that you will be able to install this Metal LB. Yeah, so just taking one more slide for this part of this workshop is sidecar deployment. So basically the core of our service mesh is a sidecar. Basically, it's a envoy proxy. Now, if you would not ask your customer to configure your platform or framework level information in each and every YML of in each and every deployment aspect of a customer microservices. So what Istio has provided is there are two ways you can configure or deploy a Kubernetes workload, which can be easily configured in service mesh. One is a namespace injection. So what we do is we add a label in the namespace, okay, and that label serve the purpose like it has been monitored that if a particular label, a namespace has this particular label, so what it would do is all the application getting deployed inside that namespace will get injected with sidecar. Okay, so this is done by mutating webhook, one of the feature in Kubernetes, which is mutating webhook. What it does is a server will be running, mutating webhook server will be running. So for each and every resource workload which you are going to deploy on that particular namespace, so it would be watching on that particular namespace. Okay, for instance, okay, so I have these many namespaces. Okay, but what I have done is I have configured only default namespace for sidecar injection. So what I did is I ran that I ran the command, this one. So what I did is I added a label in the namespace, default namespace, which is Istio injection enabled. So if you see my namespace, okay, sorry. So you can see this label over here. So further to this, all the application which I'm going to deploy will have a sidecar along with it. If you see all this application, whichever is deployed over here, has two containers running. One is the envoy proxy sidecar, and the other the service itself, the workload itself. So if I have, I like to choose or try to inspect. So what I can check this. Okay, so if you see here, there are two containers running. Okay, one is detail container itself, and other is Istio proxy itself, which is actually a envoy proxy sidecar. Okay, so this I have not used. So if you see my workload, right? Okay, sorry. Let me see. Platform. Okay. If you see over here, my workload doesn't have that information, like envoy proxy. It is being injected through mutating webhook. So you can see only one container I have, but once it is deployed, it has been injected by this service proxy sidecar. So this is one way. Uh, so what you can do is all the you label a namespace. So all the workload which is which is deployed inside this that name particular namespace will, after the label injection label adding the label, all the workload which is going to get deployed inside the namespace will have a sidecar injected, and that will be that will serve in, and that will be added. Like if you have the sidecar added, so that will be part of service mesh, Istio service mesh. The another way is like a manual injection using istioctl command. So what we can do is for each and every workload, right? Like book information, I need to run this command istioctl kube inject -f this file. So what it would do is it would generate a YML file. Okay, with like statically it would inject that information, and it and further I need to again apply the kubectl apply kubectl command to deploy it inside the Kubernetes system. So if I have to do this one, what I'll just sample. See, so you see, okay, yeah, you see over here, it added all this information, like init container test added and service account, and finally it has added the container information. Yeah, you see container. Okay, you see yeah, this is the sidecar. This is a sidecar added over here. But if you see actual YML, if you see the actual YML of this workload, you would not find that. So these are the two ways you can configure your services inside the service mesh. Istio service mesh basically. Yeah, so this is the first part of the Istio demo, and then we are gonna take a pause over here, and then I think 10 minutes should be sufficient enough, what I feel, and then we will join again.
So Amit, would you recommend something what they should try it out for?
Yeah, sure. Yeah,
Is it the same link which I provided right now in the chat?
I think this would be the better one.
Okay.
Yeah. To deploy
Okay,
the
cool.
complete
So,
Istio, yes.
yeah. So we gonna take 10 minutes break. We can come back at 12:10. By that time, you guys can try installing Istio. We'll be there live on the chat. So if you guys face any problem related to the deployment, we will help. Okay.
Sure.
So let's meet at 12:10.
Mm.
By the time, do you guys have any question? Any of you guys? Question, doubts, suggestions, anything? Okay, so let's meet 12:10. Whether you wanted to tell something? Hello. Yep. So I think we are back. Can people give thumbs up if they're back? So, no. Yeah, I see most of you guys are not back, so we'll just wait for another 1 or 2 minutes.
Pavitra, I think we should start. Otherwise, we would not be able to finish.
Yeah, I think we'll
time.
get started.
Yeah.
Meanwhile, participants, can you just raise your hand and say, or maybe give a thumbs up, and we'll get started. At least 1 or 2 participants, we're good. Yeah, Shekhar is around. Okay, thanks for the confirmation, Shekhar. We'll get started, Amit and Asif.
Okay. So before moving to the traffic flow, I'd like to ask if somebody has tried out installing service mesh in due time and faced an issue. You can quickly fix that, and if not, just I'll just move. Okay.
I think we'll move on now.
Yeah,
Amit.
let's move on to the traffic flow. So okay, Istio has defined some CRDs, I would say, and based on those CRDs, different decisions are made. Okay, so those CRDs, I mean, if you see, those CRDs will actually impact the flow of the complete service to service and from client to service or user to service traffic flow. So the major CRDs are virtual service, destination rule, and gateway. Okay, just like to you can see this is the gateway CRD, virtual service, and the destination rules. Okay, so these are the CRDs which Istio defines, and these are the actual configuration one administrator has to do to do the traffic management in the service mesh. So each and every entity has its own particular role. So I'll just start explaining one after that. Like virtual service is an abstraction which decouples the actual service name and to the actual service which is gonna get connected with it. Because you see, your services as you move pods are ephemeral in nature and everything, and those services, right? Because microservice has one feature, something called each and every microservice can be owned by one team, and those teams can independently develop those microservices. So if they have to interact with each other, they have they are maybe the actual service name which we are familiar of, like Kubernetes service name, may be different, and maybe test environment might have something different, the production environment might have been different. So what virtual service does is it brings these two things together. One is the name with which the service will going to get identified, and the actual service name which is there on the platform itself. So it helps for the client and server to communicate with each other. So let's say if I am a client, I have to connect to some server. I do not know what the actual service is there on the Kubernetes. So what I can use is the placeholder name. So host would be that placeholder name, and that name I would use. I will say, like, as a client, like, I want to connect with this one on this particular URL and connect with me, connect with it. So what it does is eventually the request will go to the service proxy, invite proxy, and that invite proxy will translate based on that mapping, like, and that mapping will be given through this virtual service, that if some client is trying to connect with this particular host, so this is the actual service which is it is actually intended to connect with. So that will be the actual route. So that is the coupling between these two, like the placeholder name and the actual service, which is one of the different, which will be defined through virtual service. Not only this.
Amit,
Yes.
one quick thing.
Yep.
I think Region is in waiting room. Can you let him in and continue the session?
Oh, sure.
Only host has the access. Sorry.
Okay. I do not see someone waiting or. Reason. Okay.
I think he had some audio issues, so he has disconnected and then connecting again.
What I need to do: mask, host rename, put remove, put in waiting room, allow in multiple.
Yeah, just do allow in.
Allow. I do not see anything. allow to multi-pin or allow to record local files.
No, you don't see anyone in waiting room.
I do not see anyone in.
I think Region is in. I think he's connecting to audio. Yeah, I think we are good, Amit. Go ahead.
Okay. Okay, wait. Yeah. So so virtual service not only bringing these two things together, but also it helps in grouping the services, all the traffic which is coming, right, which can be redirected to different services. With a single virtual service, you can have multiple services underneath, and for each and every URL you can direct it. So the client can use the same, and a group of application can be represented by the same virtual service. You see what I mean? Like, in a single virtual service, placeholder name foo.com, you can have any number of services down, service A to A, B, C, D, and all such things. And each and every service, right, would serve with the same name, but on the different URLs. That could be one scenario. Other thing is, the same service can have multiple versions. Okay, so maybe in some scenario like canary deployment, or maybe A to B testing, all such scenarios, right? We can use this virtual service and can have two services running side by side, and can be used. I mean, the client can use the same host name to connect both, and you can also divide the traffic. So virtual service has all such virtual service abstraction provide all such configuration with which the two services can communicate, and those controls will be provided by the virtual service. Okay. Now, second is a destination rule. So virtual service is basically where the virtual service handles whom to connect with, but the destination rules handles how those traffic will be handled at that destination itself. So what we do is, like, a host is the actual name of the service, and you can have any number of versions defined, and also you can have TLS TLS certificates, breaking and circuit breaking, load balancing, and all such rules can be defined in the destination rule. So it is like how you want your destination to handle it, because both these services, both this abstraction are basically first handled by the proxy, right? What I mean to say is, like, if this is one and the other one is this one is the other service, the first thing it would do is to connect the service proxy itself. So both the information, the virtual service information and the destination rule, both will be part of this proxy itself, right? So if this guy has to connect with this one, so the virtual service will be applied here and the destination will be applied here. So it will be applied one after the other. So first the virtual service will be applied, and then all those rules will be applied, and destination rules will be applied later on. So each and every abstraction has a different role in the network flow. Now, okay, now virtual service can have any number of rules. Likewise, destination rules can also have any numbers of rules, and those will be applied in sequence in the same flow from top to down, and it is or in nature. Like if you have defined let's say 6 rules and any of them is success, so it will pass through. Same goes with the destination rule. Okay, now gateway is one such abstraction which, so virtual service and destination rules, right, both are dedicated to inbound traffic, like ingress, egress, or service to service communication. For all those things, virtual service and destination rules are applied. But the gateways are actually a separate set of entities which is at the border of service mesh. Okay, so all the configuration and the policies which is applied to gateway will only be applied to that border, like envoy proxy running at the border of the service mesh. So for an example, I would say, so if you see, I told each and every application in the side this is part of service mesh. So there are service proxy running in each and every pod, right now. But again, there is some pod, separate pod, which is which handles the ingress and egress of your traffic, which is like the traffic coming from outside or the traffic going from out to out. Okay, so these again both will be having envoy proxy itself, but they will be handling the gateway configuration. They will be basically using gateway information to let any client connect with any services inside the service mesh or anything which is going out, right? That will also be going through the gateway itself. So that's where the gateway helps. Okay. Okay. Yeah. So basically, as I mentioned, like this, you can see in this flow that this is this green line and blue line. Blue line is the logical request. So basically, what it means is if client want to connect to service X, so it will go through the service gateway and eventually end up over here. But actually, it would have gone through the actual path from here to here or some here to here. So that way. So virtual services and destination routes are basically the abstraction or logical entities which will act as a policy or the configuration you say, and those will be given to the envoy proxy, and that helps to direct the traffic based on the policies configured in virtual service through virtual service and destination routes. The gateway are the endpoint of traffic, like for the border of the service mesh. Okay. Okay. So before that, I would like to show something. Okay. No, this is one example of like that is the theory part of it. Like, but if you want to see the actual abstraction, how it looks like is this. Like it is a virtual service, which is a CRD kind, and then this host is the actual name, the placeholder name. Okay, and these two things are the information which helps to direct the traffic with this placeholder name. Let's say if client uses reviews, then to which all services this reviews placeholder name can be used to direct to. So what we have is one route, so it would be host. So now this host in destination would be the actual service name. Okay, so if you see in our Kubernetes, okay, yeah, this one. So this is the service reviews, so which is over here. So I mean, in the example, the name use same, so which is misleading, but these both host, this one and this one, are different. These are the placeholder names, so which will be used by client, to connect with a specific service, and these are the services configured over it. So which all services it would with this name it would connect. So also you can have very specific in services, as because it is OR, right? So first this services, this rule will get applied, then again this rule will get applied. So any of the rule satisfy, it will pass through. So if you see this tag, so it is like for all the user, right? JSON user route to V2. So this virtual service looks like gets interpreted like this way, like all the clients which like to connect with a review name should be directed to if it is matching with if it is header has an end user called JSON, then direct it to V2, otherwise direct it to V3 for all the requests. So this is how virtual service looks like. Okay, if you see different kind of different kind of functionality which you can use for virtual services. Let's say this one. Okay, yeah, this would be more appropriate. Example. So host name is the placeholder name, like it would be like bookinginfo.com. Now over here, what we are doing is these two matches, right? So for with the same name, it will go to reviews or rating. Okay, so based on the URL, the traffic will with the same placeholder name, like host name, it would go either to the reviews service or to the rating service based on the URL prefix. Okay, likewise, we have different virtual service use cases. Some of them is timeout. You do not want, like, though some the basic features to ensure the reliability of your services, right? Like circuit breaker, retry, timeout, all those things, right? How you can configure in Istio is through virtual service. So basically what you can do is, this is the one, you can say that for the destination, right? Timeout for this one. If it doesn't serve in 10 seconds, just timeout, return with the error response. Okay, so whoever client is trying to use, trying to connect with the ratings, if the response has not came in 10 seconds, it will time out, and the response is gonna send back to the actual service which has used to call it. Okay, similarly, retries can be configured. Okay, so rating, if route is this one, and then retries attempt is 3, pre-try timeout is 2 seconds. Similarly, for circuit breaking features can also be configured. Okay, yeah, circuit breaking is a functionality which is for the destination rule. Okay, for fault injection, right? So what we do is to ensure, let's say this particular feature is basically useful in the scenario where you actually want to inject fault in the system so that you can test the resiliency of your system. So if it is a fault, it would definitely generate one error. So you can see whether your service is able to handle that particular error or not. So that way, that level of testing and the production scenario in simulation and all things, such things can be done with the virtual service abstraction itself. Okay, so these are some of the use cases which we have through virtual service, which is supported in Istio itself. Okay, I believe I have taken care of virtual service. Now let's talk about the destination rule. So virtual service is something which mostly is for the initiator, like client is gonna the invite proxy from where the request is gonna get initiated. The virtual services is for those invite proxy. But what if the request reaches to the destination? So what about that? So what it does is this is the actual host we have configured, and this is the default traffic policy. So we are this is the simple load balancing. So whatever request is coming for that particular service will be load balanced randomly. But you can also have subsets. So here we can define different versions, right? This name doesn't mean anything but the labels. So these labels will help us to identify which service serves to which 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 application serves to which particular version. So this is to identify the workload, and this V1, is, if you see this one over here, virtual server. Yeah, if you see this one, subset V1, that is the name used over here. So virtual server, on virtual server, you can specify that connect me to this particular service of this particular version. So from where the virtual service an envoy proxy will get the information that this is the version, this particular application is the version of V1, right? So that is coming from destination rule, basically. So in the subset section, what you can define is the label. Based on the label, the different versions are defined. You can see over here. And for each and every version, you can define the load balancing policy like this. Okay. So destination rules are basically to segregate different services and based on the versions, and also you can define the different load balancing policy over there. So based on that, the request will be load balanced across multiple instances of that particular service. Okay, now
Hey, Amit,
okay.
one thing. I think Region is having problem again.
Okay.
Do you want to check once if anyone is there in the breakout room?
Okay. Still on hold. Okay. I'm not sure.
Now click on participants. Then on the topmost, you'll see
Participants. Okay, I have clicked that one on. I think Roushan, he's connected, right?
I think he's having some issue with his audio.
Are you able to see the participant
I see.
pop-up box? So you can see, right, that
Yeah, I see him.
right?
Yeah, Region, do you have any issues? Like, can you confirm once again? We already see you here. Anyway, go ahead, Amit. I think we're good.
Okay.
No, he has audio issues, so he's trying to join from his phone, it seems. So that's why he's trying for the second device. But yeah, Amit, I think he's pinging on the chat.
I could not see the chat also.
Okay, no worries.
Okay.
Yeah, just go ahead. Please.
Okay, thanks. Okay, so I will be giving the demo of each of these, if each of these virtual service and destination rules, so that we can see in real how it works and also stuff. Now, gateway. Let me just give one more like bookish knowledge so that we can move on to the actual realization. Okay, now gateway is one more CRD with which this is mostly for the border of all the traffic which is coming either coming in to the mesh or going out. All those configuration can be done over here. So this is the selector and this is the app which is been wherein this will be applied to. Okay, now this is the server. So what we are doing over here is this is the host. Okay, and this is the TLS communication. Okay, credential name. So this server, right, this port, for this port and this particular server is being allowed to connect, but to whom? So that again needs a virtual service. Okay, so virtual service, we define that, okay, for this gateway, whatever request is coming will end up going over here. Okay, so this is how it is. So either for destination or for the gateway, for each and every entity, your virtual service is required, which is the actual routing entity. Okay, so if I have to draw the analogy, it will be like cluster IP. Either you create a load balancer or node port. Eventually, it has to come to cluster IP, and then eventually it will get forwarded further to the respective services. So So once you configure this, so you are so basically what it would do is it would the gateway. Okay, now first of all, gateway is an optional entity. You can have, or you may not be needing it. Like, but the other alternative of gateway is the ingress. So again, ingress will provide you all such information and everything which is supported by gateway, but the extra set of functionality which comes with the service mesh, like your observability and security, you might not get. Like it, all the traffic which lets up on the gateway, right, will be audited. The metrics collection and everything will be done, and all those things will be done by default, right? It is out of box solution, right? So but if you try to install the ingress, right, you might have to reconfigure it, or the anyway the ingress controller process would expose the traffic, expose those metrics and observability information. But again, you need to devise a separate system. But with the gateway, because it is out of box solution from Istio, so gateway would be much preferred way of exposing any services from the mesh to outside. Okay, so this is what, again, like ingress, gateway also connects with the load balancer, okay, and will create a interface like load balancing IP, and will expose that IP. I mean, for the same gateway information, like for this particular server, is load balancer services will get created, and that services will be used to connect with the actual entity, like actual services. So for an example, I can show. If you see here, I have one Istio ingress, okay, and I have configured a gateway. Yeah, okay. So, okay, sorry. So for this gateway, I have been assigned to a load balancer with this particular external IP. So if I need to connect to this gateway is actually I have used for exposing this service, basically yeah, this bookstore app, right? I'm able to access from my browser, right? Even though my complete system is deployed in a virtual box. If you see, I have a virtual box and the complete VM is deployed over there, but still I'm able to access it from my Windows portal, because I have exposed it to the load balancer, and I have set up a port forwarding mechanism for the same load balancer. If you see here, port forwarding, and this is the pod for which I have forwarded for this particular port and this IP. So I am able to access it from the complete thing. Otherwise, I would not have been, like, again, I could have done the port forwarding for the actual services again, which may lead to the issue. But what I've done is to use the ingress gateway itself to connect with a particular service, so which is exposed as a load balancer. Okay, so that is pretty much about the traffic flow. So the major entities which we need to know for to govern or to manage a traffic inside the Istio are three entities, like gateway, virtual gate service, and destination route. So if you know, and you know the each and every attribute of those, you will be able to manage the traffic within the mesh. Okay. Now coming to the pattern. So clubbing together all these three CRDs, we can have different patterns defined in mesh. These patterns are basically, you can say, design patterns, like mesh design patterns, like reusable patterns, which can be used in service mesh to solve a specific set of problem, like request routing. So what you can do is you can use virtual service to target, if let's say you have 3 version of services, you can use the request routing to just direct instruct the traffic management systems to just direct all the traffic to a specific version of microservice. So I'll just show a demo of it. Like if you see now, I can connect to, you see, okay. So you can see each and every time I refresh it, the traffic is coming from the responses have been served to different microservices. I hope you guys remember this application. So all the reviews are being served from these three microservices, same microservice with a different version. This will not have rating. This two will have rating, and this rating is based on like the color coding is being defined. So either it is black or red. So that defines the version, either V2 or V3. Okay. Now currently there are no such like a pattern or the virtual service pattern has been defined. So the traffic is coming from each and every microservices. So if you see, it is for V3 now. Okay, now it is hanged now. Yeah, now it is coming from V1. Now it is coming from V2. So let me add a policy which, okay, and I'll just explain that policy, and I will be a little fast because we are running out of time. So okay, see, this is the routing request. I will be opening this one and show it. So if you see, what I'm doing is I'm routing each and every request to V1 only, but if the user is JSON, it is directed to V2. Okay, so let's try it out now. Okay. Okay, now once it is applied, now I have not signed it with anything, so it should always come with V1. See, it is always coming. Anytime, any number of time you request, it is always going to come with V1. Okay, now let me sign it with this thing. JSON, I think that is the name, right? Sorry, guys. So currently we have tested this one. It is always coming from V1. Now I'm gonna I'm gonna sign it with the just user, and then it should come to V2. See, it is coming from any number of time you do refresh, it is always gonna come from the same thing. Okay. If I delete it, now all the red should come now. Yeah, you see, red has come. So this is how we can from administrator, you can manage and maintain the traffic between different microservices in Istio. So this is one thing, which is one which I have explained, one pattern called request routing. Now let's talk about the canary, wherein what we are doing is we will gonna do is to first direct all the traffic to one version, and then we will split the traffic into different version, V1 and V2, and then eventually we will direct all the traffic 100% to a single microservice. So that would be like a real use case of canary deployment, wherein if you have deployed a new microservices, new version of microservices, what you would like to do is direct 50% of traffic to the new deployed one, and then test out whether it is working fine. If it is working well, we direct all the traffic to the latest microservices. So yeah, so I'm just going to copy paste all this thing. So what this does is it will direct all the traffic to V1. What guy will do is it will split, okay, 50% traffic to V3. Let me just open it and show it to all guys. Okay, so you can see for all the reviews, destination is 50% weight and 50% weight. So it would go V1 50%, V3 50%, and eventually what we are doing is we are directing all the traffic to a single entity called V3. Yeah, you see this one, because we are using the changing the same virtual service with the name reviews. So it will gonna just keep changing that, and that changes will get reflected in the invite proxy immediately. So that's what we are trying to do. So let's do follow the steps. So what we are gonna do is direct all the traffic to V1 first. So if you see, V1 is without review. So see, no rating, sorry, no rating. So V1 is no rating, V2 is black, and V3 is red. So all the traffics, any number of time you refresh, all the traffic is always gonna be directed to the V1. Now what I'm gonna do is I'm gonna change reviews virtual service, and then the traffic will be split in two. So if I refresh, hopefully, yeah, you see, it is been directed to V3. Again, refresh, it might change. Yeah, you see, it will keep changing every time I refresh. Yeah, you see, at the red and back to this one. So 50% traffic will be shared between two, V1 and V3. Now what I'm gonna do is I'm gonna switch all the traffic to V3 now. Now any number of time I refresh here, it will always be red. Any number of time I refresh, it has always been red. Okay, so this is one pattern, canary pattern deployment. I'm not sure. Pavitra, do we have some time? Because I think I have two more sections to cover.
Yeah, you can extend, Amit. Maybe another 5
okay.
10 minutes. Yeah.
Thanks, guys. Please bear with me because service mesh is such a huge topic to cover. So, okay, I'll just try to wrap up as soon as possible. But yeah, just bear with me. Okay, fault injection is something which we have discussed just now. Which what we are doing is we are gonna this section, all the traffic is gonna be V1, and then what we are gonna do is we will route some of the traffic with some name to V2 and some traffic with same V1. Now with this one, what we are gonna do is we are gonna insert a delay, which is a fault. Okay, so if I'll just open this one. So if I log in with JSON user, then I will be getting a fault because there is a delay of 7 seconds, and I would not be expecting the 7 second delay in API, sorry, in a microservice. So I will be getting an error. But if I do not log in with JSON, I will be every time I will be getting the information from V1, and there will not be any issue. So I'll just quickly copy paste everything so that no issues. Okay. Okay, now let me refresh it, because if you see, let me just open this. Okay. If you see, Okay. Rating should always come from V1. So basically, rating is coming. Because rating is coming, there is nothing over. I mean, we can see the stars, but as soon, okay, so let me just, okay, yeah, sorry, my bad. Because if you see this one, I have not logged in with any user. Okay, so you see there is all the requests are being served from V1. Okay, now if I log in with JSON, hopefully it should get a fault. Let me sign in with JSON. Some issue or something. Okay. Okay. Yeah. This. Yeah. You see, I am logged in JSON and I am getting an error. Sorry, product reviewer currently unavailable for this because I have added a fault for rating system, right? So if rating is not able to serve the rating, definitely we will not be able. The review system will always say that okay, because rating is not available, review will always will. But as soon as I log out, and yeah, you see it is able to serve the ratings. Okay, but it is always this one. But okay, let me delete everything, and then I think it will be back to normal. Okay. Okay, not found. Okay. Now I think it should back to normal. Yeah, see now the request has been served from every places. Yeah. And by the way, you can see, okay, I'll just come to that part. Okay, so this is fault injection, which is helpful to test out if there is, if you want to test the like especially like error scenarios, or you want to do something called chaos engineering. This would be one of the helpful tool for you guys in service mesh. Now there is something called circuit breaker. I have pre-configured all these applications. So what I'm gonna do is just quickly, I'll just show like so what circuit breaking is like to increase the reliability. If if out of multiple instances of services, if any one of them is down, so all the requests going to that particular microservice will be halted inside the service mesh itself. It will not be forwarded. Now eventually after some delay or something, it will again retry to send one request to the microservice. If it is still down, it will again halt. So some of the services might fail, but most of the time it will try to shift the incoming traffic to the healthy one. So that is what circuit breaker is. So let me just, I think the application is already available. Let me see HTTP bin. Sorry. Okay, yeah, it is available. Okay, now yeah, I just open this circuit breaker YML for you guys to see how it is. So you see, this is destination rule. So what it does is basically it is allowing only maximum connection of one. If more than one connection is there, that will be halted. Okay, and it will be retried after this 1 second, like whether it is free or not. So if we do a single request, it will be success. If we do multiple requests in parallel, definitely some of them will fail. So that is what this thing is. So if you see this export, so this will be giving the client pod name, and then I'm doing exec and doing a request. So you see, one request is successful if I do a single request, but let's say I do a parallel request, less than 20 requests. Okay, then what would be the scenario? Because I think I have applied the circuit breaker. Okay, so you see, 40% of the request is failed and 60% is successful. Okay, so this is how circuit breaker works. Okay, now I think I have explained most of the pattern. Okay, mirroring is one pattern which is missing. So this is a special case where what you can define is you can define a virtual service wherein all the traffics coming to a particular microservice can also be copied and sent to a different microservice. This is especially helpful in the scenario where you have a production environment. You want to do a debugging forms of for a flow. So what you can do is you can have a particular system and all the traffic will be like the production application and the test application, both will be running on the same cluster, and some of the all the packets of a specific microservices will be directed to one more microservice, like it's a copy. And the test microservice, you can have a debugging point and also stuff, and you can test out what is the actual issue which is going on. So these are the different patterns. Okay, this is not the exhaustive list of all the patterns. These are the some patterns which I wanted to highlight, which help to shape the traffic inside mesh. So yeah, that is what I have for this thing. Okay, I think I have already discussed ingress gateway. So yeah, expose service outside of the mesh, and also coming traffic is manage inbound traffic, and it is a layer 4 to layer 6 load balancing. So basically you can have TCP, you can have HTTP, also load balancing. I mean, you can have these filtering and load balancing primitives inside a gateway. The basic advantage I have, as discussed, like the instead of using Kubernetes vanilla ingress controller, we can the ingress gateway of service mesh will help you to manage those traffic by default, but additional set of information like security, TLS termination, and then the basically observability features will come in handy. I mean, it will be out of box, will be available. So always suggestible to have a ingress gateway. Now coming to the security, which is the like for any product, this is the basics and most section to cover. So I'll just quickly take you through. Like it supports two things: the authentication and authorization. The authentication is between peers, like between service to service is authentication is there, and for each and every request which is going to work, going for a workload, for that also authentication is supported. So basically we are ensuring for each and every request, and if there is a communication between these services, those are also supported. So how it does is basically, is this visible to everyone? The diagram is visible?
Yes, Amit, it's little blurry, but yeah, it's readable.
Okay. Sorry. I tried to fit in, but okay. So I'll just try to be as vocal about it as possible. So what it does is basically, as soon as you deploy a service, for each and every service, a new certificate will going to get generated. Okay, and that certificate will be issued by Citadel. Okay, so as soon as you deploy a particular service in over here, proxy agent will be running alongside the workload, and that proxy agent will ensure all the certificate generation and will communicate, basically that will communicate with Istio D, which has exposed gRPC interface for certificate generation rotation. Okay, So what it does is that proxy do a CSR, certificate signing request to Istio D, and Istio D issues certificate for each and every workload. So which will be the unique identity. The certificate itself is a unique identity for each and every workload. Now the unique name for each and every platform is different. For Kubernetes is the service name. Okay, so service name will be the unique identity for that particular workload, and for that same service name, a certificate will be generated by the Istio D through CSR. Okay, now those certificates will be available for each and every proxy over here. Now, if one service want to communicate with the other service, what it does is using the same certificate, it will try to connect with this particular service, let's say. So now this service, what client will do is, because it's they are using MTLS, like mutual TLS, so both will exchange their certificate. This will send that its client certificate to this service, and this will send a server certificate to this particular proxy. So what client will do will check whether the certificate is valid or not, because all of those certificates are signed by the same root certificate. So it will be very easy. Like you can use the root certificate public key and decrypt it. So if it is decrypted, so basically it is signed. Like this is a basic mutual TLS flow, where a client use the root certificate public key to check whether the server certificate is signed by the root certificate or not. If it is, then client is okay. But the server side, what it does is it has first it validate whether the certificate is valid or not. That is authentication. The second, two more additional information what it do is, so two more action what it do is, it keeps the name server side for auditing and authorization purpose, because he should know, right, the server, that for this particular request, whether the client which has made the request, even though it is valid, authentic user, whether it has a sufficient permission for this particular operation or not. And if it is not, or if it is, in both the scenario, it will log it as an audit log, and that will be exposed outside as an observability point of view. Okay, so this is the complete flow of authentication, what it happens inside Istio. Okay, now, okay, oh sorry, this is only for peer-to-peer, and for request authentication, what it does is basically any request it does. This is just one thing. The request authentication, what is for each and every request, it will be each and every request should be added with a JWT token. So currently it supports JWT, JSON Web Token. Okay, so using that JSON Web Token, so there is a mechanism in JSON Web Token. It has 3 sections. So basically, so the end section will will be encrypted by the certificates. So if it has been encrypted by the same root certificate, so basically the web token is correct. Okay, and the each and every request which is for like a service request, right, which will be validated, that it is an authentic request. Now second is authorization. Okay, so for authorization, each and every request, right, where even though it is an authentic user, will be authorized whether the workload has a permission to do that operation or not. So this all for authentication and authorization, there is a separate CRDs through which you can define those policies. So you can say that for these all this particular service, like this particular service can accept request from, let's say, workload B only. So that kind of authentication and authorization can be done with this primitive, like security primitive. Okay, those all policies can be defined. Like there is an authentication policy, so that will be taking care of that thing. Also, you can have like this particular request can only like different verbs of HTTP also can be used to ensure the authorization policies. Let's say workload B can do only get request, not put post or all such stuff. Okay, not only this, end user also, right? They also, if they are connecting to any workload, they are also supposed to have a particular JW, JSON Web Token. Then only they will be able to request a particular workload. So that thing will also be ensured. So currently, there is no authorization API. Sorry, no authentication primitives added. So I'm easily able to access all the requests. But if I add the authorization primitive, so I would not be able to do, because my client is coming, ingress is coming from here, and then if I apply a work authorization policy saying that do not accept anything or accept from this workload, if even though ingress and everything is valid, I would not be able to connect with the workload A, because straight away proxy will say that, okay, you are not authorized to perform this particular operation. So we are able to perform, or like we are able to control, not only shape the traffic, we are able to control the traffic also. So within the service mesh, and all those things can easily be administrated through STOD. So what you can do is authorization or authentication policies will from the administrator can be configured over here, and this will be pushed down to the each and every proxy. The same set of things can be done. Okay. Okay, I can show how it is, and quickly wrap it up. Okay. Yeah, you see peer authentication, and peer authentication is like whether this particular is authentic or not, okay, is here. So what this is the default authentication, right? MTLS is strictly each and every request, each and every communication between two microservices should follow MTLS. That is what this policy is for peer authentication. Okay. Okay, you can also have like peer authentication, like for this namespace, if any application, right? Let's say this application, you should have the strict policies to do MTLS communication. This is for authentication, and then again we have authorization policy. So this is how the authorization policy normally look like. So if you do not specify, that means nothing is allowed. If I apply this policy right now, I will not be able to communicate with any microservices, even though the product page also. Now there are multiple variant of multiple attributes added. So what you can have is, this is a selector of that particular. So if I apply this, okay, and later on I apply this one, okay. So what it would do is, it will see, okay, this is the for this particular product page, right, application. So this action is allowed for only get. So we have rules, actions. Okay, now one thing I have missed is, for authorization there are only two kind of action, allowed or blocked. Okay, so either a particular rule is allowing or blocking, there is nothing beyond that. Okay, and this is and any of them is failed. Okay, like earlier the virtual service were all right, any of the rule, right? If it is allowing, it will allow, but this is like a short circuit. It is, if any of the rule do not allow to pass through the traffic, it will immediately fail and will send an error response. Okay, so that is about authorization. Now observability. So like as discussed earlier, the observability has three pillars, like metric, tracing, and logs. So metric is all about the different, all kind of metrics, whether it is service to service communication, any traffic coming from outside, gateway, or any metric on gateway related to request, related to policy, related to operation, related to any such things. Even the metric related to the process, all those network like flow, net traffic flow metric will be provided by Kubernetes service mesh by default. So all this anyway, the proxy in-web proxy is in the path of data plane. So all these metrics are mostly exposed through in-web proxy. So so there are different subsystems like Python Prometheus, Grafana. So Prometheus, what it does is it scraps all those metric information from each and every sidecars, and it maintains it, and eventually Grafana is a visual representation of it. I think these like Prometheus, Grafana, all these things comes as an add-on. So you can just simply say add-on deploy. Okay. So those, okay, let me just give that add-on section. I think whatever link I have shared initially, right? Will have that add-on feature. So if you do apply the sample add-ons, right? So it would deploy. It would deploy the Grafana workload, Prometheus workload, Agar workload, and Kiali workload. So basically, Prometheus and Grafana is for metric collection. Okay, this is for collection, scraping basically, and this is for the visualization. I can show that right away. Yeah, if I have started it, yeah, you can see this. There is no traffic currently. If you see, yeah, okay, I think it is not up or something. Really, okay. This is how you can run the browser from add-ons. Okay, yeah. So if you see, I've started a Grafana dashboard. I'm not running browser on the host system. I'm trying to access from the Windows system. So that's why address and port has been given. Okay. Now I think I should be able to connect Grafana. Yeah. So you see, these are the default dashboard populated. Okay. So you can have mesh related dashboard, service related. So you can see in general, there is nothing. Okay. Currently, now if I try to do some request, should have some information over there. Okay, now I should have some information populated. Yeah, you see some informations are coming over here. So these are the service dashboards. You can have workload dashboard also. You can see that in general. Yeah. Inbound traffic. See, this inbound traffic has come recently, just now, whatever I have done operation for. Okay. Performance dashboard you can have. So these are the requests which I have just made, and these are the performance aspects of those things. So yeah, so basically our Istio comes with a default collection of metrics and all. Only thing is the add-on services, the side services has to be get deployed, and because it supports open telemetry environment. So all other subsystems like Prometheus, Grafana, Agar, and also system should be able to scrap all the information which is required to be get, and then can be presented. Now Agar is used for basically, yeah, this UI is for end-to-end tracing. Again, this has been deployed. So you can see for each and every request, which all services it has connected with. Okay. And what all the time it took. And yeah, you see it took 32 milliseconds to serve this particular request. So each and so you see it has this particular request that went to the default in client. It came to ingress and product page and the review system. Okay. Now this request has come till here because anyway the products page is the portal page, and then rating default it goes to reviews, it goes that way. So these all been served from rating and then reviews, and this is only review. because we have three services, right? The three kind of services, one which only is one which do not have rating altogether. Which I think, yeah, over here we do not have one a service which connects with the rating, so it doesn't go to rating. Only review, only two version of review microservice v2 and v3 connects with the rating. So this is evident from here also. Only review, you see, only review, it goes to review and came back. It from here it goes to rating and then review, and then it will serve back that way. So you can see each and every. Okay. Also, you can, if you just click on this, you can see how much time it took on each and every service, or for each and every service. So you see, product page this much, the end to end, it took this much. Okay. Default, it took this much, 2.5 to review, it took 4. This much. So you can trace back each and every entity where the request has been and where it is not, and all such stuff. Also, if it fails, right, it would also display why it failed and what is the error response being sent and also stuff. Okay. Okay. Now the most interesting is okay, I was explaining all this tools and for observability, and the most interesting is Kiali, because it gives end-to-end visibility of a microservice, and it would have all the information which Grafana and Agar has. Also, it would, you will be having a nice representation of all the configuration, the topology of the application, tracing and health. If you see the yeah, this is the console. Okay, so if you see graph, okay, so okay, error loading. Okay, maybe my services is down. Okay, okay, this is the one. Okay, I think I need to restart it. Yeah, it came back. So you can see these each and every entity is microservice. Currently there is no data, so nothing has been. But if I just run it a couple of times, okay, now we should be able to see a nice representation over here. Yeah, you can see which all namespace. Okay, yeah, different version graph it is. So you can see which all places is connected with what all the things it has done. You can have any app graph you can have. Okay, yeah. No, I think this is version graph. Yeah, you can see this one. This is Istio product page, review, rating, and everything. You can see all the application deployed in the service mesh workloads. Okay, these are the workloads. You can have Istio configuration. See, these are all the configuration we did, right? This is the review system. You can see the complete destination rule and everything you can have over here. The services, which all services is added as a part of mesh inside this service mesh. All are available over here. Okay, see, host path service is missing sidecar and everything, because host path service is something which I have deployed, might have deployed before, and not after injection. Like I enabled a default namespace injection, right? I think this host path service might have been deployed before that. Okay, these are the workloads we have. No workloads found. Okay, it is fetching all information. Okay, yeah, these are the workloads we have: rating, review, this process project page, these two things. And most interesting is the graph part, where you can have all the services graph, traffic, default, and version graph. Yeah, this is visible, more visible now. Okay, so this is what we have in service mesh, all the square capability and functionality. I think I've mostly tried to cover squeeze in. Okay, I think, yeah, the sidecar proxy, virtual service, destination service, and service account, everything has been configured, discussed. Now, okay, I think this, Asif. Hello. Hello.
Yeah, Amit, I think we can skip this one. So already we are
Okay.
running late here.
Yeah. Thank you, guys. This is me. And this is the workshop presentation we have. Feel free to ping us on our LinkedIn or Slack channel, or if you face any issue related to Istio, we would be able to help you guys.
Hey, Amit, we have one question from
Okay.
Frank on the chat. So is it yourself for us if you can take?
No.
The question is, does using service mesh have any overhead on performance of the monitored applications?
Performance overhead. Okay, I would say there is a small overhead in the sense of because we have a sidecar. So sidecar, if you have a service in between, there is some like if you have end-to-end connectivity between two microservices, definitely the performance will be much better than not much better, but if you see the performance data, right, the heat is very less. I would not be able to give the data, but I would also not say that the performance it is not there, but it is very marginal in respect of whatever functionality and features it brings in. But there are works going on to remove the sidecars for each and every workload and deploy a single sidecar on each and every node, which actually brings more performance. But current implementation and whatever we have has some hit. Yeah, that's correct.
So, Amit, first of all, thank you very much for amazing session. So when you say moving the Istio ambient mesh, right? What's your opinion about that? Like moving from sidecar to waypoint proxy or cTunnel implementation, will it break anything like a vendor neutral kind of implementation? Because maybe I'm not much expert on that. When we say service mesh, typically the most of the architecture in the sidecar proxy, right?
If I get your question correctly, you wanted to check about the architecture point of view, right? Is there any issue if we brings in service mesh? Do we have to do a lot of modification and optimization? That's what your question is.
Yeah, something like what you mentioned, right? The moving from sidecar to some common kind of node level or namespace level proxy.
Okay. So no, that will not have that. I mean, it will not change. Yes, because what changes we are bringing in Istio is the framework level. So once you do changes in framework level, the workload should not be impacted. So yes, if you do changes, if you are going to migrate from sidecar to the node level in Envoy proxy, definitely I would say no, there will not be any impact on workload.
Okay, thanks, Amit. So one more curiosity question. When you say observability, right? Overall observability solution. So it will be only in the infrastructure layer alone, or we can track internal application activity as well?
No, it is always related to the network reliability. or network stack. Yeah, it will not. So if you say like if you want to get the CPU and memory of a workload running, no, it would not give. Or it is always related to observability of the mesh, not related to any workload running on the mesh. Yes.
No mechanism to track inside the application anything happen, like a database connectivity, or it can track only the HTTP outgoing
TCP
request
also.
or TCP
also, and gRPC also, and everything is done like protocol level. Yes, because you see this thing, it is invite proxy is 4 to 6 level, 4 to 6 layer 4 to 6 load balancer. So yeah, you will be able to configure TCPs also.
Thanks, Amit, once again.
Yeah, welcome.
Yeah, Amit, we have another question from Roushan. Does it make sense to have both ingress controller and service mesh as a part of same cluster?
Okay, I would say this is totally on use case. Okay, if you see that your deployment and your solution basically so basically if your solution is ported to service mesh, you would not need ingress. But if you see your solution cannot be completely ported to service mesh, definitely you would need an ingress controller.
So basically, if you have your cluster and in that cluster, the application of the workloads running is not just microservices, there are other things as well.
Yes.
In that case, ingress controller will be required, otherwise service mesh should be in.
Yes. No, if your complete solution on service mesh, I would say you would not need an ingress controller. Service mesh gateway is sufficient enough for you to handle everything. And it is as performant as your ingress, because ingress is again depend on different solution, right? If you use nginx or invite proxy or something, even invite proxy has ingress controller. You can use that also. But yeah, performance, like invite proxy has been optimized in such a level that the performance is always, it is very good, I would say, because in the production environment also it is given a reliable performance. It is always good. So did I answer the question? Maybe I hope I have answered the question.
Okay, sure. I think in the interest of time, any further questions shall be answered later.
Yeah.
Maybe you can raise your questions to KCD Chennai, and apparently we can share the same to the speakers. And thanks to our lovely speakers who had spent their weekend with us and give a comprehensive session, making the more theoretical session more lively and more interactive, and giving us as much as possible in a small session like this for 3 hours. So thanks a lot, Amit and Asif, once again. And thanks to the attendees as well who have been patiently waiting and listening to the session and being more interactive. Thanks, guys. And
Thanks, everyone.
yeah, and look up for this KCD channel, as in like you have a in-person event which is going to happen sometime in July. So you can come in person, whomsoever is in and around Chennai. So that's going to we have the venue details as well given. So yeah, and we also I think we had blogathon and quiz. I think they are closed, and we'll keep you posted if there are any event coming up in future. And we'll have these workshop sessions going till second week of July. So the next session is going to be on next Saturday. I think blogathon is still open. The quiz is also open, Pavitra.
Yes, it is open, and maybe
Okay.
it would be more workshop centric. Like maybe you guys who have attended today's session, you can just quickly check out the quiz and try to submit. We are happy to award you with some prizes based on the answers that we get.
True. Yeah. And also, I think it's more generic questions on Kubernetes, so anybody can try it. Okay, then have a good weekend, and thanks a lot, guys, once again. See you then. Bye.
Thanks, everyone. Have a nice weekend. Thanks. Bye-bye.
Thank you. Thanks all.
Thanks.
Bye.